Welcome to Sri Chaitanya IIT Academy. Today we will be discussing JEE Mains Physics question paper that was held on 25th February, Shift 2. Please note that these questions are based on students' memory. Let's look into the first question. A solid sphere as shown is rolling without slipping. Find maximum length traveled on an inclined plane. Okay, now we will apply principle of conservation of total energy. Now this is before and this one, it climbs up to this, let me suppose. Okay, now if this length is L and this particular height will be L sine theta. Okay, so the climbed up height is potential energy. So finally we'll have only potential energy because this is going to stop here. So kinetic energy will be zero. Now kinetic energy is zero because it stops here. Now this is after climbing up. Okay, I'm speaking of after climbing up. Now this is equals to, now before will be, now here we have kinetic energy. In fact, it is rolling, and for that reason, it will have kinetic energy translational and plus rotational kinetic energy. Okay, and this is on the ground. Potential energy is considered to be zero, and for that reason, here potential energy is mgh. I will get mg vertical height. I take L sine theta. Okay, and plus 0 I have. Now kinetic energy translational here, it will be half m v naught square plus now half I omega square I get. So now I omega square for a solid sphere, as he says, is I will be 2 by 5 mr square. Okay, so now half I omega square will be half m v naught square plus half 2 by 5 m r square omega square. Now r square omega square will be v square, and for that reason I write half m v naught square plus 1 by 5 m v naught square I get. Okay, now on solving this, you are going to get L value from here, and L is equals to 7v square by 10g sine theta you are going to get. And this is the first option. Next one, please. In an amplitude modulated wave, message wave frequency is FM and carrier wave frequency is FC. Find out wavelength of amplitude modulated wave. Now, wavelength is actually lambda is equals to V is equals to n lambda. Velocity is equals to wavelength into frequency. From there, we get C by FC will be the right one. Move on to the next one. Okay, so now I have a unit mass particle is moving in a circle of radius r such that its projection on diameter executes simple harmonic motion. Okay, in 0.1 second time. Now this time is equals to particle undergoes angular displacement 30 degrees. Find force acting on the particle at B. So now this should be B, I believe. Okay, if it starts from A, now R is equals to 0.36 he has given. Okay, now we have F is equals to mr omega square. In fact, okay, now if you look into this mr omega square, we are given with radius 0.36 is given. Okay. Now, in fact, I believe some data of unit mass. This is okay, 1. Okay, R is 0.36 and omega square, I don't have the data. Omega is equals to angular velocity theta by t. Theta is given as 30 degrees and 30 degrees is pi by 6. Okay, so 30 degrees I have, this 30 degrees is pi by 6. So I'll be taking this as pi by 6. Okay, and the time is given as 0.1. Okay, so F is equals to 0.36 and omega is pi by 0.6. I'll get, now this will be theta by t will be pi by 6 into 0.1. Now this is squared. Now on solving this, and you are going to get F is equals to pi square. Now pi square is equal to 10 in fact. Okay, so that may be approximately equal to 9.7. Now this will be the right answer. We'll move on to the next question. Sunlight is diffracted through a circular aperture, circular single slit diffraction. This is diameter is 0.1 meter, 1 micrometer. If diameter is slightly increased, then what happens is the question. Now we have d sine theta is equals to n lambda. Now this is single slit is going to form Aries disk, and this A for Aries disk, the condition is d sine theta is equals to 1.22 lambda. Okay, and then in fact we need to look into sine theta. Sine theta is equals to 1.22 lambda by d I get. Now size of the circular aperture is the, if diameter is slightly increased, so d is increased, d is increased. Now this the fringe, if d increases and the fraction value decreases. Okay, so now what we need to get is size of the circular fringe will decrease and intensity is going to increase, will be the right option. Okay, move on to the next problem. So proton and electron are moving along circular path with same speed. Find out ratio of de Broglie wavelength. So he says same speed. Okay, so de Broglie wavelength lambda is equals to h by mv we have. Okay, now de Broglie wavelength for proton and electron. So lambda proton is equals to h by mass of proton and velocity is same, for that reason I put, and I have lambda electron is equals to h by MEV. Now he is asking for the ratio. When I divide this, so I'll be getting lambda P by lambda E is equals to ME by MP. No, his interest is lambda E by lambda P. So lambda E by lambda P, invert the ratio. So MP by ME, you are going to get. Okay, so when we take this mass, it is 1837 times. Okay, so 1837 times 1836 precisely. So this will be the option. So we'll move on to the next question. Find out dimensions of this expression where E is the charge. So IT I need to go for, and epsilon naught is permittivity of free space. H is Planck's constant. So 1 by 4 pi epsilon naught Q1 Q2 by distance square I have is equals to force. So 1 by 4 pi Q1 Q2 by distance square F is equals to epsilon naught. Q is IT whole square and I don't need to consider 4 pi. So distance is L square, force is MLT minus 2 is equals to epsilon naught, what we have. Now H is E by nu, and this is ml square T minus 2 by 1 by T. H is this, and c is speed of light, and c is equals to LT minus 1. When you do this, do the proper analysis, and we are getting the dimensionless quantity for this. We'll move on to the next question, please. Okay, so in a given AC series circuit containing elements R, L, and C and source voltage 220 volts, it is known that if L alone is removed or if C alone is removed, phase difference between current and voltage remains 45. Find IRMS given the resistance of the circuit is 110 ohms. And for this sort of situation, since this C alone removed or L alone removed, the phase difference is going to remain constant. The meaning is phase angle is going to remain constant. For this is resonance circuit, and for this resonance, IRMS is equals to VRMS by impedance, and that is 110 I need to take. Okay, so this will be 220 by 110. I'm going to get 2 times. Okay, so this will be 2 amperes, and this is the first one. Okay, so eighth one, rotational kinetic energy of a gas molecule follows Maxwell's speed distribution curve. Rotational kinetic energy and translational kinetic energy of a diatomic gas molecule is same, he says. Now this according to Maxwell's distribution curve, it's always drawn for number of molecules versus velocity of molecules. So I feel that this statement 1 is not right. Okay, and I feel the statement 2 is also not right, I and this one seems to be the right one, please. Now first one is false and second one is also false. Okay, so we move on to the next question. Now, if an electron of a hydrogen atom jumps from n is equals to 2 to n is equals to 1, then find the wavelength of released photon. Now, energy is equals to minus 13.6 1 by n1 square minus 1 by n2 square I have. So minus 13.6 1 by 1 minus 1 by 2 square I have. Okay, and he's asking you find the wavelength. Now this is energy. Now if I want energy, energy is equals to, I will be getting this energy in electron volts to find 12400 lambda in angstroms will give us energy. Okay, so or I can put 1240 by lambda in nanometers. Okay, will be energy here, what we get. Okay, now I replace this. Okay, so energy I replace 1240 by lambda I'll get, and 1240 by lambda in nanometers is equals to, now ignoring this minus, now 13.6 1 minus 1 by 4 I take, and we need to estimate the value. When you properly do this mathematics, you are going to get this as 121.5 nanometer, and which is the first one. We'll move on to the next question. In photoelectric effect of a certain metal, the stopping potential is 0.7 volts. If the wavelength of the incident radiation is 491 nanometer, okay, now the stopping potential comes out to be 1.43 volts if the wavelength is incident on the radiation. So Now 1.43 if wavelength is instant. So we have two sentences and two equations. Okay. So, and we have h nu is equals to the stopping potential h nu naught plus work function. Okay. Now this is hc by lambda is equals to work function. Now this is I take this as work function. So I put this as h nu as it is plus ev naught I take. Now this is better done in this manner. Okay. H nu is equals to W plus KE. Let me put, and this is the work function what I have got, and this will be EV. Okay. So now this will be, since lambda value is given here in nanometers, so let me put energy is equals to 1240 by lambda in nanometer. Okay, so this energy is hc by lambda, so that I put 1240 by this 491. Okay, is equals to the work function, and for this equation first sentence 0.71 is the energy, that is kinetic energy, and for the second set of the equation next sentence stopping potentials comes out to be 1.43. Okay, so the stopping potential is becoming 1.43. I need to put in this place 1.43. In the place of V, I'll be putting 1.43 plus the work function, and that is equals to, and I will be getting this, the wavelength incident I'm interested in. Okay, so this we have no idea. So 1240 by lambda. Lambda is not known to us. And for that reason, I have taken in this manner. And if we go for proper mathematics of subtraction one from the other, and we are getting lambda is equals to 382 nanometer. Okay, we'll move on to the next question. Two particles having m1 is equals to 4, m2 is equals to 16 grams. If kinetic energy of both the particles is equal, okay, then ratio of their momentum n is to 2. Okay, so now he says kinetic energy of both the particles are equal. The meaning is k1 is equals to k2 now, and I will write p square by 2m is equals to p2 square by 2m2. Okay, so he's asking us ratio of the momentum, and for that reason I will go for p1 square by p2 square is equals to m1 by m2. And so we'll be getting m1 by m2 is 4 by 16, and this is p1 square by p2 square as given here, 4 by 16, and this is, and if I want p1 by p2, now this will be under root 1 by 4, and it gives 1 by 2. So we'll move on to the next question. An electron enters in a capacitor making an angle alpha with one plane having kinetic energy K1 and comes out with kinetic energy K2 making an angle alpha beta, making an angle beta with other plane. Find ratio of K1 and K2. So let me suppose, and the entry I take it, and this is V1, and the exit, let me take in this manner. Okay. So in this case, if this is making an alpha, and here with the other plate it is making beta, I resolve this into components. Now V1 cos alpha and the vertical component V1 sin alpha, which I'm not interested. Now this is V2 cos beta, and this is V2 sin beta. Now, here these two should be equal, and because they are horizontal and these two are oppositely directed, there is a change in vertical component. Okay, and for that reason, I'll put V1 cos alpha is equals to V2 cos beta. Okay, and SOBS squaring on both sides, V1 square cos square alpha is equals to V2 square cos square beta. Okay, so, and he's asking you ratio of kinetic energies K1 by K2 is equals to half m V1 square by half m V2 square. Now this gets off. V1 square by V2 square is equals to cos square alpha by cos square beta from the above equation. When I substitute this, V1 square by V2 square will be the answer, and V1 square by V2 square is cos square beta. I'm sorry here. So we are getting cos square beta and cos square alpha here. Cos square beta and cos square alpha. Okay. So I'll be getting this first option, please. Move on to the next one. Okay. So a gas follows PV power half is equals to constant, and V2 is given as 2V1. He is asking T2 by T1. So the meaning is PV raised to the power of half is equals to constant. Okay. So when I convert this into TV relation, it comes out to be TV minus half is equals to constant. Okay. Now the meaning is T by root V is equals to constant, and that is equals to T by root V. And if I put suffixes, now this will be root V2 I need to have. Okay. So he's asking us to find T2 by T1. Now T2 by T1 is equals to root V2 by root V1 I get. Okay. So now V2 and V1 are given. V2 is equals to 2V1, and this is root V1 is given, and T2 by T1 is equals to root 2 we are getting. So the second one will be the right option. Move on to this. Now for given logic gate circuit, which truth table is right? Now this truth table, we need to work with each of these, and then you are going to get it. Now this A will be A here, and this will be A bar, and this B will be B here, but this will be B bar. Okay. Now this will be A into B bar, and this will be A bar into B, and here it is OR gate, NOR gate, and A B bar plus A bar B, and this will be whole bar. And when you do it properly, you are going to get this as the right answer. So we move on to the next question. Match the columns. Okay. Now this transformer will be step up or step down. Okay. Rectifier, it converts AC to DC. Okay. Filter. Now filter removes the ripples. Okay, so this is going to remove the ripples, and this holds good, please. Okay, we'll move on to the next question. Now these two are in parallel. The springs are in parallel, and find time period. He's asking now t is equals to 2 pi root m by. In fact, I need to sum these two in parallel. So this will be 2k plus 2k, and we will have this one as the right one. Okay. So after that, a particle starts performing SHM on a smooth horizontal plane, and it is released from x is equals to a by 2, and it's moving in negative x direction, then phi is. So it's moving along negative x direction. Now, if I take this to be x-axis, and this is moving towards negative x, and this is positive x if I take, and this as y, and this will be here, it is moving, let me suppose, and I have this width to be a by 2. Okay, and this is, I have from here to here 90 degrees, and this is theta if I suppose. Okay, so now apart from theta is pi by 2, and we have additional angle. Okay, phi is equals to theta plus pi by 2. I need to write, in order to find what is theta, y is equals to, I take a cos theta. So this will be cos component here. Okay, a cos theta, and y is given as a by 2 here. Now, y is given as a by 2. Now, I should prefer this as x, because this is done on x-axis. X is equals to a cos theta, and x is given as a by 2. A by 2 is equals to a cos theta, and I get cos 60 is equals to half. Now this is pi by 3 is equals to theta. So phi is equals to pi by 3 plus pi by 2. Now when I substitute it here, okay, so this place theta I have taken. So you are going to get this as 5 pi by 6. So we'll move on to the next one, please. Okay. Now, for an extrinsic, this is impure semiconductor. If doping concentration is increases, then now we need to look into the options. Okay. So for n-type, p-type Fermi level will increase, T is greater than TF. And for n-type Fermi level will increase, and for p-type Fermi level will decrease. Okay. For n-type Fermi level will decrease, and p-type. Now the variation of Fermi level obeys the conditions that of mass action law and neutrality equation. And for that reason, the second option is the right one, please. Okay. Now, if tension is increased by 4% in vibrating string, find percentage change in speed of wave, he is asking. Okay. So we have velocity is equals to root tension by mass per unit length. Okay, take log here. So log V is equals to half log T minus half log mu. You get, differentiate it. Okay, so dV by V is equals to half dt by t. Now this is constant, and this constant differentiation will become 0. So I'm not considering this. And if this is the case, he has given us some data. He is asking us 4% is tension is increased. So if T is equals to 100, then dt will be 4. and I substitute this, half is equals to 4 by 100. Okay, so I will be getting this as 2%, 2 by 100 I'll be getting, and this is equal to 2%, and 2% will be the correct answer. We'll move on to the next question. Now, if P cross G is equals to G cross P, and angle between P and G is theta, and theta is between 0 to 360, then value of theta. Now, P cross G, G cross P is possible only in a straight line. So, P and G, if they are along a straight line, then only it is possible. And this is the angle between them. And for that reason, this theta, whatever we have, is equals to pi or 180 degrees. Okay, we'll move on to the next problem. Okay, a satellite is projected from surface of Earth so that it can attain 10 r height. Okay, so if the height is r and another 10 r. Now, height from surface of Earth, he says its speed at surface of Earth is v escape root of x by 11. He's asking us to find x. Now, total energy, we will apply here principle of conservation of energy. So conservation principle of energy, the total energy. Now, potential energy plus kinetic energy at the surface of Earth. Now, total energy at the surface of Earth is equals to total energy at this particular point, where the velocity will be 0 here. So velocity is 0 here. And in that particular case, now on the surface of Earth, now this point, let me write total energy minus gmm by r, the potential energy, plus half mv square. And then about this particular point, let me write so minus gmm by 11r, the total height, r plus 10r, and plus 0, velocity is 0, and for that reason. Okay, now when we properly do this calculation, so I'll be getting v is equals to v escape root 10 by 11. I'll be getting. So we are interested in this particular value. Okay, this 10. So x is equals to 10 here. We'll move on to the next question. Now this current is splitting, total current is splitting here, and I is equals to I1 plus I2 I have. 6 is equals to I1 plus I2 I have. So we employ Kirchhoff voltage law, minus 2 I1. From here I'm starting. Okay, so minus 2 I1 again here. Okay, now plus 2 I2 is equals to 0. I get, now 2 gets off. Okay, so I2 is equals to 2 I1 I get. So now in this one, I substitute this particular value, substituting 2 in 1. 6 is equals to I1 plus 2I1. So I1 will be 6 by 3, and this will be equal to 2 amperes. Next problem, please. The Carnot engine W by Q is equals to 1 by 4 if sink temperature is decreased by 52 degrees centigrade. Now the Carnot engine efficiency will become W by Q is equals to 1 by 2. Find out source temperature. Now W by Q is efficiency, and this is given as 1 minus T2 by T1. Okay, and this is given as 1 by 4. Okay, so when I transfer this 1 minus 1 by 4 is equals to T2 by T1, I get 3 by 4 is equals to T2 by T1. Let me mark this as equation 1. So we have a second sentence. Okay, so it says W by Q is equals to half, but here 1 minus the temperature is decreased, sink temperature is decreased. So T2 has become now 52. T minus 52 by T1. Now we need to work out with this particular equation. And here when we work out, you are going to get T1 is equals to 208 degrees centigrade. Okay. So we'll move on to the next question. A particle is dropped from top of a tower when it has traveled a distance 5 meters. Another particle is dropped from a distance 25 meters below the top of a tower. If both of them reach the bottom simultaneously, then find the height of the tower. Okay, so now u is equals to 0. Now 5 meters. Okay, another particle is 25 meters. Okay, so this is S1. Now S2 is equals to 25 meters. Now this is U is equals to 0. Now at this point, in fact, now this is being dropped. So these two have, when the ball is here, now this is dropped here. Okay. If both of them reach the bottom simultaneously, then find the height of the tower, he says. So the reaching point of this and this is same. So these are reaching simultaneously. And he's saying that they are same. So the velocity here, root 2 GH, root 2 GH, G is 10 I take and H is 5. Okay, I'm going to get this as 10 meter per second. And time taken, V is equals to U plus 80. So here 10 is equals to 0 plus 10t. Now t is equals to 1 here for this particular position. Okay. Now we have delta time is equals to relative displacement by relative velocity. Relative velocity. No, relative displacement will be S2 minus S1. Now, relative velocity will be about this and this particular velocity, what I have. So, relative velocity will be 10 minus 0. I get 25 minus 5 by 10 is equals to 2 seconds. Now, 2 seconds. And you know, the first particle has already taken 1 more second. Find the height of the tower, he says. Now, the time taken by first particle is equals to 1 plus 2 seconds. So this will be 3 seconds. Okay. Now, the height will be equal to S is equals to UT plus half AT square. Height is equals to UT plus half GT square. And U is 0. We have half into 10 into, we have 3 square. And here we are getting 45 meters. We'll move on to the next question. For a X-ray, if its wavelength is 10 angstroms, mass of a particle having same energy and same wavelength as X-ray is XH by 3. So what does this mean? So, you know, mass of particle having same energy, energy is H nu, and H nu is Hc by lambda I have. Okay, so and this Hc by lambda, I will be considering this as the kinetic energy. In fact, I'll be considering this as half mv square is equals to Hc by lambda. When I divide and multiply with this, I will be getting this p square by 2m is equals to Hc by lambda. Okay. Now P square will be h square by lambda square, and 2m as it is, I take hc by lambda I am going to get, and from this I can strike these. Okay, so my interest will be m, and on calculating m is equals to, I will be getting this as 5h by 3. Proper substitution will be 5h by 3. X is equals to 5 I am getting here. We'll move on to the next question. Okay. Two conducting charge particles of negligible volume whose charges are 2.1 nanocoulomb minus 0.1 nanocoulomb respectively are brought in contact and then separated by 0.5 meters. If force of interaction between them is x into 10 to the power of minus 9 Newton, what is the value of x? Now, this Coulomb's force, I'll apply 1 by 4 pi epsilon naught. So now this will be, now this will be 2.1 minus 0.1 will be 2 nanocoulombs evenly distributed between these two after getting separated. And for that reason, this will be now 2.1 plus 0. Minus 0.1 will be 2. And when they are separated, now each of them will be getting 1 nanocoulomb and 1 nanocoulomb. So 1 into 10 to the power of minus 9 I take, and coulombs formula I am implementing, and the separation distance is given 0.5 squared. This is, and I'm going to get this value as 36 into 10 to the power of minus 9. And we are interested in x value. X is equals to 36. And we could collect this many questions. Okay. So this is from the student's memory. And all the best for your future exams. Thank you.